So what we do in CYK is to fill this table with variables. Okay, so in each cell we write the variables that generate the string, the substring that corresponds to that cell. Okay, so we are going to use sets of the form bij, which are the variables that generate the substring that starts in the position I and have length exactly j. So they go up to position I plus j minus 1. Okay? So for instance here we have the variables that generate exactly the string whose only symbol is s1. Here we have the variables that generate the string whose only symbol is s2. Here we are in length 2, so we write the variables that generate the string that starts in s1 and ends in s2. Here, this is length 3, we write the variables that start in s1 and have length 3, so they go all the way to s3. Here, for instance, we are in length 2, row 2, so and we are in the last but one column, so we write the variables that generate the string that starts with the last but one symbol and have length 2, so they go up to the last symbol of the word. Okay, so when we have this, the set bij, I is the initial symbol and j is the total length. So we have initial symbols in the columns and lengths here in the rows. Okay, and well, first of all, notice that it's impossible to have symbols here or here, because here we need to start in the last symbol of the word and have length 2 because we are in row 2. But if we are in the last symbol of the row, of the word, we cannot have length 2 because then we miss one symbol. We need more symbols in the word. Okay, so what we are interested in is in the content of this cell here, the last cell in the only cell in the last row of the table. Why? Because here we have the variables that generate the string that begins with s1 and have length sn, length n. So they go all the way until the last symbol of the word. Let me write this n a bit better. Okay, so this is the whole word, and we want to know what are the variables here. If the variable, the axiom s of the grammar is there, it means that s generates that string, it generates the complete string. Okay, so our task is to fill in all this table and then check whether s is contained in this last cell of the table. Okay, if we are able to do that, we can check whether the string is generated by the grammar just by taking a look at this last cell of the table, the only cell in the last row. Okay, that's our goal. So we need to know how to fill in all those cells in the row, in the rows of the table. Okay, so the first row is very easy to fill because It corresponds to strings of length 1. And remember that we have already uh, shown that strings of length 1 in grammar in Chomsky normal form can only be generated directly with a production of the grammar. Okay, so these are the variables that uh, directly generate one of the symbols of the word. Okay, so the first row is very easy to fill, because if we want to know which variables generate, for instance, the substring whose only symbol is b, then we only need to look for those variables that directly generate b. Okay, so the first row, very easy to fill. What about the other rows? In the other rows, we need to look for variables that generate the string that starts with symbol in position I and have length exactly j. Okay, if it is if j is 2, if it is uh, one of the cells in the second row, then we are looking for substrings of this form, a symbol and another symbol. Okay, and we know that these um, strings can only be generated from a production that generates two variables, and then each of those variables generate the variable the terminal s1 and the terminal s2. Okay, so we are looking for variables that produce pairs of variables, and the first of the pair generates s1, the second of the part generates s2. Okay, so what we are doing is in fact dividing the word into two parts. Okay, and for longer substrings, we need to consider all the different ways of dividing the string into two parts. Okay, this is what we are going to use in the algorithm in order to fill in all the cells in the table. Okay, so what we are going to do is to follow an order that will allow us to make this computation in a very quick way. We start by first filling the first row. The first row can be filled directly, as we have mentioned, just from taking a look at which terminals are produced with which variables. Okay? There is nothing else that we need to do. For the second row, when we want to check, for instance, whether what are the variables in this set, remember that here we are generating the words of the form S1, S2. And we need variables that generate a pair of variables, let's say A and B, and A generates S1 and B generates S2. So we are looking for variables C that generate A and B, and then A generates S1, B generates S2. But since we have already filled the first row of the table, all the variables that generate S1 are already here. These are the variables that generate S1. And these are the variables that generate. Wow. Okay. Well, doesn't want to work. Okay, now. And these are the variables that generate S2. Okay. So in order to fill in this cell here, we need to take a look at this cell and this cell and see what variables generate at the same time one variable that is in B1, 1, and a variable that is in B21. And those are the variables that we are going to write in B12. Okay? In the same way, in order to fill the cell B22, we need to take a look at B21 and B31. Okay? And the same for all the cells in the second row. We just take a look at, for instance, for this cell, at the cell that is exactly above the cell that we are filling in, and the cell to the right of that cell. Okay, and with that we have all the information that we need in order to fill in the cell. Okay, what about the cells in the third row? For instance, let's say that we want to fill in this cell here. Then remember that this cell corresponds to the variables that generate S1, S2, S3. And we have two different ways of dividing this word into two parts. The first one is S1 and then S2 and S3. And the second one is S1, S2 and then S3. Okay? And we want variables that produce a pair of variables, the first of which generates, for instance, this part, and the second one generates this part, or the first one generates this part and the second one generates this part. Okay? So when we are filling this cell here, we are looking for variables that generate pairs of variables. The first of one generates this part and the second one generates this part, or the first one generates this part and the second one generates this part. But which are the variables that generate this part here? This is S1, so this is exactly this cell here. And which are the variables that generate S2, S3? This is a word that starts in symbol S2, so it must be in this column, and has length 2, so it must be in this row. So we are looking at these variables here together with these variables here. Okay, so we check this cell together with this cell. Okay, this is for the first way of dividing the word into two parts. The second way of dividing the word into two parts is the one here. First, to divide this part, to generate that part, and then to generate that part. What are the variables that generate S1, S2? They must be in this column because they start in S1 and have length 2. So they are exactly the variables in this cell. And what are the variables that generate S3? They must be in this column because they start with S3 and they have length 1. So we are looking, in fact, at this cell here. Okay? So to generate the variables or to fill in the variables in B13, we need to consider the variables in this cell together with the variables in this cell, and then we need to consider the variables in this cell together with the variables in this cell. Okay, let's see what happens with the second cell on this row, this one here. It's exactly the same, exactly the same. Now we are generating S2, S3, S4, so we can divide the word into S2 and then S3, S4, or S2, S3, and then S4. Okay? And for this first situation, we have these variables, the variables that generate S2 exactly here. And the variables that generate S3, S4 exactly here. Okay? For the second way, we have S2, S3. Those that word is generated by the variables that we have here, and S4 is generated by the variables that are here. Okay, and that is exactly the same, moving everything to the right with all the cells in this row. Let's see what happens with the variables in another row. For instance, in row 4, let's take a look at this row here. Now we are generating S1, S2, S3, S4, and we can divide this word into in two ways, in two parts in three different ways. S1 and then S2, S3, S4, S1, S2 and then S3, S4, or S1, S2, S3, S4. So for this first possibility, we need to take a look at the variables in this cell together with the variables in this cell here. For the second possibility, we need to take a look at the variables in this cell. They generate S1, S2 together with the variables in this cell here. They generate S3, S4. And for the third possibility, we need to take a look at the variables in this cell together with the variables here, because this is the set of variables that generate S4. Okay, so notice that what we are doing in general is to fill in a given cell considering first, let me do it for instance for this variable here, or no, let me do it for this cell here. First, the cell that is in the same column but at the top of the table in the first row, and the cell that is in the diagonal but the closest one to the cell that we are filling in. Okay, so this is our first choice, because then with this cell here we are considering words of length 1. So with the second part we need to start just one symbol to the right, and the length should be one less than the total length of the substring that we are generating. Okay, once that we consider those pairs of cells, then we need to consider that the first part includes one more symbol. Okay, so then we start exactly in the same position, but the row is one position below, because we have length 1 unit more. And then we move in the diagonal, because we need to start in a column that is one position to the right, and in a row that is one position up, because the length of the second part is 1 unit less. We start one symbol to the right and with length one symbol less. So we need to consider this cell here. And finally, for this cell that we are filling in, we need to consider this cell together with this cell. Okay, so we always start in the same column at the top of the table in the first row, and then we move in the column one row at a time. We get closer to the cell that we are filling in one cell at a time, and in the diagonal we get we move away from the cell that we are filling in. Okay, so let me do it quickly. For the last cell in this table, we would start in the same column and in the diagonal with the closest cell in the diagonal, and then we move in this column, we get closer to the cell, and we move in the diagonal away from the cell. This is the second situation, the second possibility. The third possibility is moving closer in the column and away in the diagonal. And then again closer in the column and away in the diagonal. Okay? And we do this with all the cells in the table, and at the end we have all the variables that generate all the possible substrings of the string that we are studying, and then we check whether S belongs to this last cell. Okay, if S, the axiom of the of the grammar is in that cell, it means that the string is generated by the grammar. Okay, so this is the way that we fill the CYK table. And here in the next slide you have a pseudocode which explains exactly what we have done. And if you want to write a computer program to implement this CYK algorithm, you can do it with something similar to this. Okay? But now what we are going to do is to see an example of how to use CYK in order to check whether a given string is in a grammar or not. Okay, so let me go to the other app where I have prepared everything to solve this exercise. Okay, this is exactly the same exercise. Here we have the table already prepared to fill in all the different cells, and we have here the productions of the grammar, which are of course in Chomsky normal form, so we can use the CYK method. Okay, so in order to fill in the first row of the table, we only need to check which are the variables that generate each of the possible symbols. So here we have B, so we check which are the variables that generate B, and we only have B, so we write B here. Okay, now A, which are the variables that generate A? They are A and C, so here I'm going to write A and C. Again here A and C, here B, here A and C. Okay, so the first row is very easy. Now, for the second row, remember that we need to consider these variables together with these variables. So we are looking for variables that generate either B together with A or B together with C, in that order, okay? So we have BC here, we have BA here, and those are the only possibilities, okay? So we need to write S and A here. Oh, sorry, I want to get rid of this. Okay, and that and that. Okay, now for this cell here, I need to consider this one and this one. So I need to consider either AA or AC or CA or CC. And the only one of those that is generated is CC, which is generated by B. Okay, let me go a little bit faster with the other two cells in this row. So we have AB or CB. AB is generated by S and also by C. And CB is not generated by any variable. Okay. Now for the last cell in this row, we can consider BA or BC. BA is generated by A and BC is generated by S. Okay, those are the only variables that generate pairs of variables that we need to consider for this cell. Okay, now let's go to the third row. In the third row, we have to consider for this cell first this cell together with that cell, and we would need variables that generate BB, but there are no variables generating BB. So let's try the other possibility, which is we move closer in the column and away in the diagonal. So we need to consider either S A or S. Let me delete this to see it clearly. Either SA, SC, or AA or AC, but those are not generated in the grammar. There are no variables generating either SA or SC or AA or AC. No variables generating that. So what we do is to write the empty set here. No variables generate that substring. Okay. Now let me go quicker for this next cell in the row. We need to consider this cell first, this possibility with this possibility. So AS not generated, AC not generated, CS not generated, CC is generated by B. And the other possibility is to move closer in the column and away in the diagonal. And we would need a variable that generates BB, but there are no variables in the grammar generating BB. Now for this variable, this cell here, this part with this cell with this cell. So AA not generated, AS not generated, CA no, CS no. okay? Or SC with AC. Then we need to consider SA or SC or CA or CC. And CC is generated by B, and the other pairs of variables are not generated in the grammar. Okay, so we are going to fill in this this cell with B. Okay, now we go to this cell here. For that we need to consider first this one with this one, so the first row of the column and the closer cell in the diagonal. Okay, so BB is not generated, or SA with SC, but again SS is not generated, SC is not generated, AS, AC, none of those pairs are generated, so we do not write any variable yet. And then we have empty with B. But when we have empty in a cell, it means that a part of the string, in this case this part of the string, is not generated. It's not possible to generate BAA. So if it is not possible to generate BAA, it is also impossible to generate BAA together with something else. Okay, so it means that we cannot generate this first part, so then we cannot generate that part together with also this part. Okay, so again we don't get any variable for this cell, so it's empty. Okay, let's see what happens with this cell. Then we have AC with B, and the possibilities are A, B, or CB. And AB is generated by both A and C. No, S and C. Okay, so I think there is a mistake in the slides. Okay, please check that that is incorrect in the slides. Okay, so AB is generated by here S and C here. Okay, so this is S, C. The other possibilities are B together with AS, that will give us BA or BS, and then we also need to include here A. Okay, we also need to include that. We need also to include A there. Okay, and the last possibility. Oh, sorry. Well, let's get rid of that, and then I include the A here. And the last possibility is B with A and C, and that would give us BA and BC. That would include A and S again, but we already have those variables in the cell. Okay, so we don't need to include them again. Okay, so finally we are arriving at the last cell. We need to consider this cell with this cell, BS or BC. And BS is generated by BS is not generated by B, but BC is generated by S. Okay, so here we need to write S. And now if we only want to check whether the grammar generates the variable, the word or not, we can stop because we have s in the last cell of the table, and that means that the axiom generates the whole word. Okay, so we can stop there, and we are sure that um, the word is generated by the grammar. Okay, but we are going to complete the table and see what happens. Okay, so we have considered these variables with these variables, and now we need to consider these variables with this variable here. So SB, which is not generated, and AB, which is generated by S and also by C. Okay? Oh, and we also, sorry, we also need to consider um, BA. So we have three possibilities, which are BS, BC, and BA. So BC is generated by S, um, BC is generated by S. No, BS is not generated by any variable. BC is generated by S. BA is generated by A. So we also need to include A here. Okay, let me remove all this before, and then I include also A here. Okay, and then we consider SA with B, that gave us SB, which is not generated, and then AB, which is generated by S and C. And now we need to consider empty with AS. We know that whenever we have one of the cells empty, then we cannot generate the word in that form. And then empty and AC, again the same problem. Okay, so this is the final table. Please correct the slide because if I'm not mistaken, here this cell is different. Okay, we need also to include S there. Okay, because that's what we got with the application of the method. Okay, so this is how you apply the CYK algorithm. Please also try to do the same with the word, with the same grammar with the word A, B, B, A. And I will also upload a video with the solution for this word. Okay? Again, as in the previous lectures, if you have any question, just leave a comment on the discussion forum on the virtual campus, and please take into account what I told you at the beginning of the lecture, that the messages are not getting through. So please check the virtual campus for the new videos and for any information on possible online meetings or any exercise that I want you to solve or something like that. Okay, thank you very much again for your attention, and have a nice week.